Hey everyone, super excited to share this content with you. I'll dive straight in, and if you have any questions, just drop them in the chat. I'll get to them as we make progress here in the presentation. And yeah, today I'm excited to talk to you about the problem that you see here in this picture. So, if you are still writing IAM policies, you have the problem that's right here. So you're protecting your data with policies. You're letting a lot of your sensitive data leaking from your backend systems. So we're going to explore why this is a problem, why and how this is impacting your company. And if you're still writing policies, why uh, you're gonna hit a wall pretty soon, and you better look at this approach earlier and change courses there, because I speak with many folks that over and over reach out to us because they've been trying to solve this problem for years with IAM policies. No matter what is the system, here I'm talking about Kubernetes, RBAC, if you're like AWS, IAM policies, or whatever cloud provider that you use, is to like defining the uh, specific resources that you have and how users should be allowed or not to use them. So with that, let's get started. A quick intro here. I'm Andreas, founder and CEO here at Hoop. And before that, I've worked for Fortune 500 banks, high growth startups, and building internal developer platforms. Very focused on security because these are like fintechs, and we maintain systems for serving 100 million customers. So let's start with the basics here. So what is this IAM policy I'm talking about? And it always starts with a definition. It's a declarative resource. This is one example policy, and this is a database example where you have, let's say, this is a read policy that lets whoever has access to it read the schema A, schema B, set of tables, set of columns. So pay attention here to the level of detail that you have in this policy. And this is what you need if you're still using IAM policies. This is the level of detail that you need to get to if you want to have least access security. Okay, so that's one thing for reads. So there is a different policy that you need to write for writes. So you might not want to have people writing to all resources that they have access to for reading. So that's why it's an even more granular policy here. So fewer resources. And the third one is an admin policy. So typically, what you see is that companies will adopt a set of policies that looks like this. But and that's good. That's least access, right? So you do this and you have least access. This is not the problem. The problem is how many times you need to do this. So what we did so far is basically the work required for one team. So we got for one database, you went through all the resources in that database. So let's say this is the team that's owning payments. So you go through all the databases schemas, you find out what's related to payments, and then inside these schemas you find out the tables that don't have social security numbers, credit card numbers, because you don't want people to read this sort of information. So you need to define a subset of these resources that are not sensitive that people should be reading. And then if you want to let them write something, you have an even stricter set of resources. And that's it. Now you completed least access for team A. And that would be enough if you have a 5 to 10 uh, people development team. So if you are in this scenario, good luck, you're good to go. Now, in many instances, this is not the case. So you need to repeat this exercise for all the teams that you have. And it's, again, just a lot of work, right? So you to do this only for one database. So we are repeating this work. So imagine now, like, how many unique, if you consider a database column a unique resource, how many resources you have. I bet it's no less than 1,000 for a medium size software for one of your microservices. And that's it. Now you completed least access for database one. What do you do after that? Are you done? Can you go have fun and work on strategic stuff? Because, by the way, this is a very tiring job. And I'll tell you why. So, who holds the knowledge of which of these columns is sensitive, which of these columns are okay to be read, are not a risk for security, which columns can be written to? Because sometimes if you can't update a customer balance in a payment systems in a ledger, some systems require immutability. So the owner of this information is the development team. So there is no security team, there is no platform or DevOps team that knows, that has all the information required to write these policies. What you end up doing is having a lot of back and forth, saying, "Hey, please, product team X, can you please tell me, like, what are the sensitive fields in your database? Because the security team, we got flagged by compliance because you can read everything. So we don't know what you are reading from the database." So we're starting to get at why this is an impossible solution. And there are a few reasons why we got here. And I want to explore briefly as well, because this system was designed, so the traditional role-based access control, and you can like think about attribute-based access control. It's like no difference. You still need to know like all the unique resources. It's not a matter of RBAC. So this concept was created in the 80s, and it worked well up to the 2000s because that was before the cloud. So most software companies were running their systems in one or two servers and one database. Maybe they had 5 VMs, 10 VMs, and that used to be enough. You can get away with that system if you have a very limited number of resources. But if you think about the cloud and the number of resources that we have today, this system just breaks. Okay, so with the cloud, we haven't changed the way we are solving this problem. And we need to do that right now because I'm tired of talking to teams that get to us and say, hey, like I've been spending years now to try and catalog all my resources across my different cloud providers. And I'm using different like data loss prevention systems to scan the information automatically. It gives me a nice looking report. And then what do I do with that? I need to look at it and write, if I have like 50 developers, quite a lot of policies. So this system broke, right? So as you start to repeat that, look at the size of this problem. We are looking at a single database. Now you multiply that by the number of resources that you have in your cloud provider. So you have multiple databases, right? If you are using microservices, you not just have multiple databases, but also multiple database technologies, which will require a completely different and new approach to this problem because they have different ways to defining policies or roles. And then you go to queues and then containers. So we're talking about if you have a 50 engineers team, about 3,000 lines of policies. To get something basic, it's not even like the most granular you can get. And you can see how this, like who's maintaining this? These 3,000 lines are basically code, production code that needs to be maintained because it's not just that you have these policies and you're done because every day developers and product teams are evolving the software, creating new columns, new resources, and also destroying resources. And you need to keep updating these policies, which is a lot of work. And this is typically not accounted for. So you have this, okay, like this quarter, we're gonna work on list access. So this is the priority for the security team. So you assign one or two security engineers. They go all the way, they go out, they try to do their best. So they create some sort of implementation of this. And then next quarter, you go work on something else. Who is going to update the policies? So typically no one. And then you pretty quickly get outdated policies. Or even worse, so another approach, and this is what most companies will do. So not everyone, most companies won't even try to solve this problem. So what they do is they basically create this, and then instead of assigning it to team A, you have this generic, very big policies that you just assign to everyone in the company. Okay, so that's also not a good idea because you're granting way more access than you should to folks, way more than they need to do their jobs because we want people to be able to access things that they strictly need to. And you end up with a system that's very, very unsecure because you just don't have the time and the ability to complete this task. So you leave it half done or almost started in the starting phase. So let's try to look at this problem from a first principles angle. What is it that we're trying to solve with that, with these policies? Like what is the purpose here? And it's very, very common that folks get lost into this amount of acronyms that we have, and with the like security, governance, identity governance, and policies, and many, many complex things. But you can forget all of that because you can isolate the problem that we're trying to solve. And again, there are very many and very complex solutions out there to try to solve this. But in the end of the day, gladly, there are only two small problems that you're trying to solve. These are simple problems, at least to understand, not necessarily easy, but simple. So the first is security. And what is security? What does it mean? What is the purpose of a security team for a technical software company? And it's really, in the end of the day, to secure the data. Okay. Why is it that you don't have the same security, the same level, the restrictiveness of your production environment in your development environment? Why is like the development environment more open? Folks can do whatever they want to do there. And the reason is because you don't have sensitive data in the development environment. So that's very important because that's what it means to secure an environment. You ensure that the data that's sensitive is not being looked at or accessed by the wrong eyes or hands. So that's it. You solve the problem of sensitive data, you solved security. So that's it. You can just have the same level of security from your development environment. You don't want, of course, to leave it open to the world so anybody can look at it, but you don't have to create strict access policies for development environments because you don't have sensitive data. So you can go with the generic policies, that's just fine. But that's not all. Again, if you're like a CISO, you're definitely thinking hard about how you're protecting data. You're making sure your data is not being leaked somewhere. But you're also caring about reliability. And you may have a shared responsibility here with SREs or DevOps or infrastructure teams. But the main idea here, at least from the security perspective, is that permissions also govern how you prevent accidental things from happening in production, okay? And we can go for the same analogy. If someone breaks the dev environment, hey, all devs are gonna be super sad. They can't test their things or develop their software, but your customers are not impacted. You run an accidental destructive command in production, now you have a big problem. Your customers are impacted. So this is one of the main reasons for policies. So you don't want folks with the access that they can be destructive to the environment that is live with customers using. And that's a lot of the concerns here for the security team. Okay. Again, like shared responsibility, there's a lot more that goes into reliability. You have code being shipped, how you monitor, you trace things, and you have observability that helps with that. But from a security perspective, you also want to ensure that the amount of access that folks have is preventing them from breaking the system or running destructive operations. So this is the problem. These are the two problems. You solve this, and you can forget about all the other acronyms and problems. Again, think about your dev environment. What if you could, from an implementation perspective, get the same amount of work that you have for protecting your development environment today for production, what would that change for you? To focus on a lightweight approach that gets only very obvious thing out of the way, and after that you get the least amount of access. So that's what we are building here at Hook. And that's what I want to show you today. It's a radically different approach to solving this problem. So going back to the two problems, if you think about reads, language models are super capable of understanding static, small pieces of information, identifying a piece of information. This is called data identification, and this has been a solved problem for many years now, even like before the LLMs. So natural language processing, machine learning can do this job better than humans according to benchmarks. So that's a job that can be automated. It has been able to be, it's been possible to automate this job for a while now. So we can solve the read problem automatically, at least from a technical standpoint. Now, let's look at how in a minute we do that. But it is possible to do it. And for writes, you're probably thinking, okay, we have breakless access workflows for writes. Nobody can write things to production. If they need to, they can request access, and someone needs to approve it. That we will ensure that they actually need to do what they want to, and it's going to be for a period of time. This is good. It's better than having like open wide access. It's definitely better than having a ticketing system or getting to a Zoom and screen sharing. The DevOps team screen shares and the developer types SQL queries in the chat app to be pasted into a client by DevOps. This is very inefficient and frustrating. Imagine the amount of teams that are at 2 a.m. woken up just to paste queries into a client because they're the only ones with access. This is a very bad way to restrict access. So let's see how we can have a zero policy approach to managing access. Okay, we're gonna have a quick break before the demo, so I'll be right back. Okay, we're back. Now let's dive into the demonstration. So what you see here, you're not seeing. What you see here is the hoop interface, specifically the web terminal. And it's basically a unified interface for any research that you want to use. You can also connect to these resources using your native clients, but this is in the browser, straightforward way to use. So here I have my database selected. I have schemas, and I can start typing my query here. Can select 1, 10, 100, 1000. You can see barely an overhead. But a lot of things are happening as I run this simple query here. First, it's being behind single sign-up. Okay. To get to this interface, I had to sign in with my central users directory. It could be Okta, GenCloud, Google Workspaces, Azure AD or Entra ID. And with that, you're already getting rid of static usernames and passwords for access to databases and many other resources. But let's stick with this use case. The second thing that's happening is that every action that I run here is being recorded and attached to my user. The third thing that's happening is I can only use this database because my user's directory or identity provider is saying so. My groups are defining which resources that I can use here. And again, going back to the policy building, this can be a generic read-only policy for all the resources because in this database, because as you can see in the outputs, the emails are redacted. And this is very unique. It's a very unique approach to preventing access to sensitive data. Because let's look at the different approaches here, even the most advanced that you may know. So the first, the most basic one is the one we talked about. So you have a team of people go over all your databases and buckets in S3 or cloud buckets. Flag what's PII, what's not PII. Maybe that's the product team or not. And then another team will define policies. Hey, you can only access this subset of fields that are not PII. That's one solution. Now, more recent approaches to this problem is saying, okay, let's automate the data identification portion. So we have this system that will hook to your cloud or your database, and we will scan it for information. We'll look for all the sensitive data. So this scan is going to look at 100,000 resources and will give you back probably 5,000, which is a lot of information. And then you have to look at this 5,000 and write policies, which speeds up a lot of the process, but probably next week, these policies are going to be outdated. So you still have a problem. And look at the size of the problem here. So why are you running these scans in the first place? It's because you want to prevent people from reading the sensitive data, your internal teams, to reduce the surface of attack. In our vision, this is a very bad approach because you're not acting on the actual problem that you want to solve. Instead, our approach is rather different. So as I try to select these 1,000 emails, who is between my developer, this client that I'm using here, the browser, and the database. And Hoop is the only solution today in the market that's not just able to look at the contents of these requests, but also change the contents in real time for a number of different protocols. In this case, we're talking about a Postgres database. And this is a game-changing thing because you don't have to proactively scan your whole infrastructure and spend months trying to write policies for it. What we're doing instead is, okay, what is the actual piece of information that your users are trying to look at? So this is a very small subset of your broader, of the larger amount of data that you have. So because of our new foundational technology, you are able to do that data identification only on the portions of informations that users are actually trying to look at. So that's why you see these emails in the output are all redacted. So the real emails are in the database, they are unchanged. So we on the fly, on the server, before these emails get sent to my endpoint, to my client, my computer, Hoop is able to analyze the traffic and redact the information in real time. What are the benefits of this approach? First, as I said in the beginning, you put this thing in front of your 1,000 databases in 1 week. We even discover we can plug to your cloud provider, find all your databases with a few clicks. You have them all here. You link it to your users directory, and then users can have permissions to databases directly from your directory. From there, you simply toggle, I want to redact sensitive information, and that's it. Now, anybody can read anything, and then no sensitive data gets out. And that, again, we have experience of rolling this out to thousands of developers, thousands of resources for large enterprises in a matter of weeks. And I'm talking 2, 3, 4 weeks. Definitely less than a month. And many times we talk to these companies and they have been trying to solve this problem for years. I'm not talking months, I'm talking years, with dedicated teams trying to write these policies. And Hoop can solve it in less than a month for that large scale operation. Not only that, but if you think about this, the approach that we're taking here and how much smaller we make the problem, how much simpler this approach is because of our ability of changing these packets in real time at the network layer. many times, so you can think about a few, like or another class of solutions that exist, which are also data redaction tools, but they would rather create replicas of your real data somewhere else. So they identify the sensitive information, create a replica, and that's what you let users see, a replicated version. So imagine about 100,000 unique resources, 5,000 are sensitive. So you duplicate the problem. Now you added another 5,000 resources to your infrastructure that you also have to manage, to govern, to put in a policy somewhere. This is really bad. So this solution is so elegant because it requires zero changes to your backend infrastructure. The only changes that you're making to your databases are probably cleaning up the many policies and the many different identities that are scattered across your database instances. You just need one read policies, and then Hook's gonna take care of the rest. So this is great. You solved the read problem elegantly with a few clicks. All databases are loaded. These read policies are automatically created for you, and your developers can start using a secure and great experience, by the way. So just open a browser. I don't have to deal with passwords or anything. How about writes? How can we do the same thing for writes? Because it's one thing you can identify, great, what's sensitive, but can you identify what is a dangerous operation? What should I let people write and what I should not? And the answer is no. So I'll switch here now to a write profile. And notice the beauty of the solution. So as a user of this system, I don't have to switch interfaces. I don't have to learn to read an internal manual on how to request a change to a specific resource in a specific environment. From the same interface that I'm used to reading information that I have direct access to, I can switch to a write profile. I can use LLMs here to help me write my query. So I just got a sample update query here from Copilot. It knows the structure of my data. So these are all columns that actually exist in the customers table, as you can see here. And just by switching the profile, I can run it. Notice here that I don't get the result. Instead, I get a prompt saying, hey, I see that you want to do that, perform this action. And pay attention to this word. I'm talking about an action. I know you want to execute this action, but this sounds sensitive. So we're going to need to request approval from some domain experts on the thing you're trying to do. So we want to get a second pair of eyes to look at this. And what is this, folks? What are we talking about here? Code review. This is a change to a production environment. And that, the best practice, the thing that we've been working and developing in the software industry for 20 years now, the whole DevOps movement. You want to what? You want to audit, you want to version control your changes with Git, and you want to code review. And Hook not just lets you do that completely automated, but also you can get requests for specific teams. In this case, DBA and DevOps. This is a database. So the teams that actually have domain expertise on this process. And you may be asking yourself, hey, this is a lot of work. How am I supposed to be approving all queries that someone needs to run? Well, this is a right operation. So the ideal workflow here is someone builds this in a development environment, QA staging, whatever. So they make sure it works. Once they want to ship it to production, this is an actual code being shipped to production, then you request a human review of the code. Again, best practice. But you also want this to happen fast. Otherwise, you would file a pull request in GitHub and have some CI/CD execute that query for you. So the reason why you would bring it here is because Hoop makes it fast. So we have integrations with Slack, Microsoft Teams, and we're going to send a notification to that team in real time in the channel. And the reason we do that is because this can scale. So you don't want to bottleneck all reviews with a specific team. So you want to have the actual domain experts, maybe this manager of that team, maybe it's some like product manager that needs to review the sensitivity of the operation from a business impact perspective. And it's all here. So the teams that this user belongs to in your directory, the actual user email, the profile, and the action. What's being approved here is the action that I want to perform, right? So it's not a break glass just-in-time approval for a period inside a privileged profile. I don't want you, if you need to run a simple fix in a sensitive environment, why would you grant someone 30 minutes with a privileged account? The risk there is much higher. So that's why we let them do one action. That's what's being approved here. So maybe these teams, they are in a different time zone. They can just open their mobile phone, see what's happening here, and say, okay, this seems fine. I see a where clause here, and this will be fine. I don't see a problem. I know this table has indexes or does not have, and they can just approve it from Slack. I'm an admin, so I'm already doing both approvals here. And then once approval is completed, the actual user gets a notification also in Slack saying, hey, the thing you're trying to execute is ready to go. Look at how fast this happened. This whole flow can happen in less than 1 minute. And we see that all the time. Compare this to, let me open this link. And you can see here, it's the same screen. I can see who approved from each team, and the execution is enabled. I'll compare this to a workflow where you have gatekeepers for a production environment. And before I can perform an action, I need to send them a message in Slack with the query that I want to run so that they can open their clients and run it for me. And they are reviewing things before they run. But then like they have this bottleneck, they have this whole backlog of things. And folks with the experience to review, the domain expertise to review sensitive operations, they should not be working with this repetitive manual thing of copy and pasting queries into clients. Sometimes companies will make it even worse. They will put Jira in the middle. So instead of a quick Slack message, I have to file a Jira ticket, put my query into the Jira ticket, and then once the team runs it, I'll get the results in a Jira comments on my query. This is terrible. It's even slower than Slack. Okay, it may grant you some checks for compliance, but the user experience of that's terrible. And what you see here, what's the impact to the business? You're typically seeing a big increase in time to recovery from problems, from incidents, a way large delay for bug resolutions because of this inefficiency. Look at how fast this happened here. So I got the permission to run this, and I can only run this action. So what is the amount of access that's being granted here, folks? And it's literally exactly what I need to do. So there's no way you can grant less access than this. It's not a wide policy that I have undetermined access, indefinite access to. It's not a time-bound session to a privileged account. It's the specific action that I want to run. And it happened fast. Now, the big question in the room here is, what was the policy that I had to write to get to this level of granularity of permission that's never seen before in a flow that's super fast? It's not safer. It's not just safer from a security perspective, but also like reliability. I can't run this without a second pair of eyes from domain experts. What was the policy that I wrote here? And the answer is one policy for your whole infrastructure. One generic write policy for 100% of your infrastructure. So you basically got no policy. We're going to write this policy for you. You're never going to have to look at a policy again. And you get this level of granularity. So yeah, as a user, I can just execute this and I see the result here. Yeah, I got my record updated. You can tell the customer that the problem was solved. If I need to run this again, maybe I need to retry it. And if I want to rerun it, I need to go through approval again. I just reset the process. So this is how you can protect 10, 100, 1,000, 10,000 resources with, in this case, it was 2 policies that we're going to create for you in the backend, so you don't have to even to look at them. And you get a more granular permission than if you had a whole army of people cataloging your infrastructure and writing these policies for you. I hope that was useful. Reach out to us if you want to learn more about the system. This is just a quick introduction. There are many other levels of permissions that we can build on top of this new foundation that we created with Hook for not just looking at the contents, but changing them in real time. Thank you, and see you in the next one.